Okay, so I wanted to talk about this real quick. I'm over at some campground, honestly. Took a lot to get here. But, alright, so this is about a piston, okay? And the piston's hollow, piston head that is, and in fact the connecting rod is as well. I talked about this when it came down to two-stroke stuffing and a couple of other of my designs for a Lemke cycle. Driving for Answer came out with a 5-stroke engine, and I was like, yeah, no, I was aware of it. I don't really consider this engine type a 5-stroke engine, but that's just because it's just going to go through the piston head into the bottomer that exists there. So I don't know what the actual technical term is. I don't really care about looking it up. That never really matters to me. The point is that it definitely is effectively a type of header that seals the chamber, you know, for where the piston goes through. Now, it's got a slightly different crankshaft, well, elbow pin more than anything, you know what I mean? It's the same crankshaft, just, you know, got an elbow pin and that connecting rod that way to that point. That allows for it to actually kind of like constantly stay very perfectly straight. However, the way it does that is because this is angled very specifically to never really allow for that to, you know, do that weird business, you know, of causing it to rub on the inside of that you know, thing. But I still have compression rings and an oil ring in there, so even if it does, it's meant, you know, to like still be able to be replaced and everything can be fixed. You know what I mean? Same thing for the, so it's hollow, so I put oil through the hollow connecting rod that goes up into the piston ring oil rings, right? So that way no longer do I need this other rotating assembly for the side of the piston, which that one was sealed anyways and it works just fine, but it's like, why would I need to do it? I mean, it's going to burn oil regardless of what I do. So instead it's just a pump now. It's a type of pump that goes up to the oil ring and it kind of like coats a little bit. It's a little bit of like almost like an oil squirter, but then it comes back down through. Now it's cooling the piston head and the connecting rod, right? Which is great. That's a good thing. But the point is that it's a circular design. You know what I mean? It allows for it to actually like have the exhaust go down to the bottom instead of having to you know, travel all the way off to the side and then over. It just goes through, and then it's the same rotating bearing ring journal kind of valve, which is a slight different than most people think. I haven't explained this in a while, but it's effectively like a branch that then has a branch, you know what I mean, that kind of thing. And what that means is like the lubrication of that gets right there, but then it seals up to its own seal like that, like a standard poppet valve, except there's lube there, right? You know, the fresh oil, hydraulic fluid, whatever version you want to go with. But the point is that when it bends, it tries to get in, all it does is actually like try and go up, over, down, up, and well, over, and then up again, and then over, and it does it like a couple of fucking, and it's like there's a lot of pressure, sure, but then there's a lot of pressure in that oil too, and it resists the shit out of that. So, and there's two of these that are countered. So there's a hole here, and then there's a hole on that side, and then this rotates off of a gear that's effectively a part of that. It gives me variable valve timing, duration, and of course, technically lift. Although it's really just a nozzle, you know what I mean? It's just the size of the opening, right? So, I don't know. Point is, it now no longer needs this exhaust at the top, and in fact, the top no longer needs a header. In fact, it's basically a reverse version. It's but then it's like it's just an engine block at that point with some drilled and tapped holes, like because I'm going to use the injectors for air, which would be fine. You know, it works just fine, honestly. Like I don't have to worry about that. But at the same time, like I also understand why some people would maybe still want to have a header. You know, I don't. It's stronger now. I don't have to worry about gaskets breaking ever, like at all. You know what I mean? And then same thing for like, oh yeah, no, it cools it, sure, but it's like I don't really want that much oil in those areas, right? And the only reason why like it's super cool is because the oil pressure itself is what actually makes it's kind of like a vacuum tension spring where that then stays up, right? And then that's the oil going down through, and so like that keeps it up there. which means I don't need any breakable parts, and since it was hollow anyways, and I just need to just stick effectively like a girdle there, right? Which I probably wanted anyways, you know, which isn't that hard to do, truthfully. Same thing for like oil squirters. It's like, this is just, you know, if I just put a thing there, then it's like it becomes a part of that elbow pin, and then that assembly goes through that and then just dips in and grabs it and fires it back down, you know, back into the crank. So now it's a dry sump basically, you know what I mean? But it's like, no, I'll still make sure it has a dry sump, right? But it's like, you know what I mean? Like, especially when it's like, we got super turbos for days, right? The moment I think about super turbos, I'm like, then just fucking get a nitrogen filter too, right? Like, I'll just dump in there fuel and that'll cool it off. I'll put just enough of oxygen in there, and then I'll burn the oxygen as it's going away, you know, into the cylinder, the burn chamber, basically. But like, you know, for what it's worth, I was also thinking like, well, all I have to do is add in like a couple of more things, and that's all it would take for that piston rod to like start having, you know, fuel and air go through it. So I've come up with a couple of those designs, but the point is, it's like a 5-stroke. I don't really have to suffer all the other issues that fucking 5-stroke does. That means I can burn into, then it goes back up. I reduce parasitic loss by the flywheel. I still capture some of that energy by basically doubling the stroke, right? And it's not really going to capture tremendously great amounts, but any amount is better than none. Especially when like I can just stick the turbine and make it more efficient that way, like a twin scroll variable, you know, geometry turbine thing that's a little bit longer, right? A little bit thicker, a little bit wider, because like that, then if I make the blades quite thin, you know, it's able to handle it because I've got a nitrogen filter just pumping in nitrogen into there, especially for the bottom as it goes back up, and it, you know what I mean? So it's like, that's my exhaust stroke, right? But then it's like, you know, I can kind of cool it a little bit with nitrogen. It goes, takes a little bit of that in there, and it goes down, and like, you know, I just dump a little bit more nitrogen in there once it closes off for the exhaust valve. That, you know, after drawing a little bit of a vacuum, right? And then it's like, you know, well then it's fine. There's no crankcase vent pressure problem. There's no fucking other issue. I dump the rest of the nitrogen off into the turbo, you know, the turbine, since I'm already like fucking filtering it out anyways. I mean, that makes it a little bit more efficient than just dump it into the crank, right? Right? Versus, because it's like you can do transmission or you can do crank. There's two there. Transmission usually means it's like a torque converter, typically with a, you know, CVT style. You know, typically like a conical, something like that is usually good enough. But like, you don't really need to do that because you can just dump it into the crank by doing the same thing. Like if you need an alternator, right, then just fucking use that. But like, you don't really need much of a spark, right? So like the spark and distributor and alternator are all now in one, right? So like just fucking run that and then just dump some coil packs at the top, which I've gotten into that even further in some of my other ideas. I'll make some more videos, but effectively I'm making a positive, well, actually I'm making a negative that then turns into a positive inside the chamber that then allows for a connect between the spark that then allows for it to then start creating this vortex generation in the hollow that allows for a detonation burn in a multitude of 10,000 little burns that then combine into like 5 little burns, right? But as it does that, of course, it's effectively dumping a lot of its energy, you know, for that positive versus negative into doing that, because that's electrostatic and electromagnetic stuff. But I was like, well, that's because there's nitrogen. I didn't have the nitrogen filter. So I was basically burning more fuel by burning off nitrogen oxide to make more fuel by explosive decomposition, which allows for me to get back that energy as extra heat and then extra, you know, oxygen exothermic energy for the amount of electricity I'm putting in, which isn't much to make that. But I need 2 coil packs and a connection point between the two. And so like the coil pack there, and then I'm making that ground out, and then I'm having that route back off as a circuit into another coil pack as kind of like a capacitor coil pack system. So that's how that works, you know, to basically get way more energy out of the system and turn nitrogen oxides into far greater amounts of energy, right? But that also means like it's no longer really kind of technically a 5-stroke, though it is kind of technically a 5-stroke, right? But it's all within one stroke. But then that's another part of my 3 combustion chamber opposed piston cylinder designs. You know, basically the same thing, but then I just souped it up with electricity, which was if you listen to those are further back, same thing essentially that I designed, where, you know, conceptually, right, that does the same, you know, positive to ground kind of circuit action, but that's from outside versus inside because I also store that exhaust for a little bit. I'm not allowing for all of it to go through, and then I'm adding in some more fuel to cool it off, but then I dump in air, or I do the opposite where I dump in air, but then I also don't like have any fuel, and so I used fuel for that initial one, but it causes a detonation, so I have to wait for it to get to about middle or close to middle dead center, and then boom. So it always stores a certain amount of heat and pressure, which is high break-mean effective pressure, but that's perfect because then I can use my waste heat generators and my turbine along with, you know, the exhaust manifold type of pipe thing that I use with a bunch of piezoelectrics and, you know, heat sinks that gain me all of that back as electricity, right? But it's like then I have to add in an electric motor, and so then I turn the piston head into an electric motor as a linear solenoid electric motor type of thing, along with the, you know, crank there effectively, and that was easy enough to do. But that's also why it's like a 49cc gives me like 500 horsey powers, but it's like I can get 500 foot-pounds of torque really quickly. So I drop it off really fast, and I go, no, but you don't want that. It's balanced to extreme degrees. You don't want it. You don't. Every time, especially when I got into this Formula One, you know, suspension dampening system, right? I was like, oh, and then I can get a harmonic balancer pump style thing, especially with like a compressor, which like I'll just stick the pump onto the back of the compressor, right? So it's like that's easy as fuck all day. I can absolutely use it. They're gears practically anyway, especially if like all of it, for what it's worth, is hydraulic fluid, oil, you know, cool. So the waste heat generator is another version of like several different things, but like it's a reservoir. It has like 3 different radiators. They're shaped specifically like a Jules Thompson, that then once it gets to a certain amount of heat, it goes, oh, the next little thing opens up, and then that reduces pressure because those are vacuum areas, right? And so like then that makes it even easier for it to phase change and dump off more. But the way it does that is it vibrates and it dumps and it creates this vortex first. So it vibrates on the way in, and then it creates a vortex while it does that, and it goes off into the next area, right? For the Jules Thompson, small, medium, large stuff, right? But okay, what it means is that when it goes off into that, it starts vibrating and it gives me acoustic resonance cooling, along with it condenses, and then that changes the vibration and it creates a pulse tube too, because it goes pulse, 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 pulse as it condenses and then goes back, and then condenses and goes back. Effectively, as that then gets drained off to the next reservoir, it goes, oh yeah, no, there's less volume there, so then I can do that. And so like it's a pulse tube, acoustic resonance, Jules Thompson cycle cooler. That's actually pretty easy to manufacture because they're just tubes essentially, and tapered the right way, and a little bit of, you know, curved little winglets, essentially stators, to make that work with a little vibration, you know, the right way. And then it does it. It's really pretty simple, but like that's also like a bunch of electricity because that's piezoelectrics in there that I use, right? And then that gives me a bunch of actual like extra energy as it expands and contracts, expands and contracts, expands and contracts. But I use a refrigerant that's also electrostatic, it's kind of like ionic, right? So it's like I'm recharging it, but not really. So put it this way, as I put an electric, you know, current through this first, it creates then with the air a different charge. This charge then creates an electromagnetic field. As that electromagnetic field occurs, and then this electricity gets generated, it dumps itself off and creates a circuit. It breaks open the refrigerant, and then the refrigerant then recompresses using the electricity it gains. That electricity it gains compresses, but also condenses it back into becoming the original refrigerant. It creates a circuit with their air, basically, and it's a part of one of my spaceship designs, right, that I'm using as a way to create a magnetosphere in a charged ionosphere to stop charged particles from hitting us and being safer, you know, in space. So that's what that was about. But then this made it so that way my cooler, my radiator here, made even more electricity and cooled even more effectively because it's even smaller and denser because of that given extra energy in our atmosphere that I can use to do this as it cools and it does the whole thing. So anyways, that's what that was. But then like I was like, oh yeah, my piston head can be made out of catalytic conversion things, which is what's going to help me with like my fucking nitrogen oxide to be bang juice now for extra fuel to be used, right? So it's like, fuck it, brrr, as I go. So I eventually just got rid of the nitrogen filter because it was like, what do I need it for? I just use it for extra energy. It's stored energy value, you know, and then as it goes through, it then goes, yeah, bang, sure. And then it goes back up and it goes bang some more. You know, standard circuit, and then I add a little bit more in from the waste heat generation and more. So like, and then I get more back, more efficient. Good stuff, right? So like that one then got me to some ridiculously high efficiency rates just off of that. That's in the 70s to 80% just from that alone, because I basically have almost no pumping losses. But that's because, you know, even the compressor alone has another version of condense and spin, and then like as there's cooling, I'm taking out that heat and then electricity by doing that, and so I'm feeding it back in, a whole bunch of things like that. And then eventually, like even the bearing journals, I'll put piezoelectrics in it, I'll fucking do it all, man, I'll fucking get it all. And then eventually I got to like 99.9 something theoretical percent, you know what I mean? And these are harder materials though, for what it's worth, but I figured out a way to make them very efficient and cheap to manufacture. So very little energy is required to make these incredibly hard materials, which is fucking awesome, right? I'm gonna have to talk about that later. Point is, this is the whole thing. See ya. Alright, I forgot to do my tagline. So, see ya, suck my dick and balls, like and subscribe. I'm gonna have to cut this. So, suck my dick and balls, like and subscribe, and share, please, and have some fun. Leave a comment below what you think about this design. Seriously, have fun. See ya.